Alright folks, we are going to be doing nuclear bombardment reactions, B-A-R-D-M-E-N-T, hitting something with something else, right? Now some of these reactions you're going to look at and you're going to say, I've seen these before because you did see them in the original podcast. Most of them are, however, new, but there's some that you see often and over and over and over, so we want to make sure that you hit those often, okay? The other thing you need to do is make sure you have a periodic table with you, because without a periodic table, there's no way you can do this. All right. So we have beryllium-9. That's beryllium. 9 is its mass. We look on the periodic table and we see that beryllium is number 4, right? And we're hitting it with an alpha particle, right? And an alpha particle is 4 and 2. Now, if we think about that, what that gives us is a total of 13, excuse me, 13 on top and 6 on the bottom, all right? And so that's what my numbers are going to have to equal. The 13 is the 9 plus 4, 4, excuse me, and the 4 plus 2 makes a 6. All right, and it says we're producing carbon-12. All right, so the 6 we've taken care of, but we still have 1 on top. So we have to put a 1 up here and a 0 down there. Well, if you have something that has no charge, but it has a mass of 1, that thing is going to be a neutron. Okay, so that's our equation. All right, berkelium-243. Berkelium is, it says it's being produced. All right, so berkelium is going to be over here, berkelium, and it's number 2. It's a mass of 243, and it's number 97, which I pick up from the periodic table. And it says it's produced by hitting americinium, which is Am, with a 241 for a mass, and 95, and it says we hit it with an alpha particle. All right? And so if we think about what we're doing here, we're coming up with 245 on top, and we're coming up with 97 on the bottom. So the 97's okay, but we have 2 too many on the top. Well, it says we're producing neutrons, and it's asking us how many. Well, a neutron is 1 and 0, and if I add another 1 and 0, right, I get a total of 245 on top. So that tells me I had to add in 2 neutrons. All right. So now this actually gives us a multi-step equation. All right, so we have to read the whole thing carefully, which I'm not going to do because I've already done it. But it says you bombard uranium-238, so I have uranium-238, and that's number 92, right? And we bombard it with deuterium, and deuterium is hydrogen, but it has an extra neutron with it, so it weighs 2, hence the name deuterium. And what that does is that is going to produce neptunium. It says neptunium-238, so neptunium-238. And if I look up neptunium, that's number 93, and it says 2 neutrons. So let's make sure this actually makes sense before we go any further. All right, we have a total of 240 on top on the left, and we do on the right as well. And we have 93 on the bottom on both sides. So that's good. Okay, but now it says the unstable neptunium decays. All right, so this thing right here is going to decay. All right. And when it decays, well, that's got 238 and 93, so it's forming plutonium. Plutonium is Pu, and it's 238, and that's 94, and another particle. So what's the other particle? Well, the 238 on top is fine, but the 93 is going up to a 94, so we need a -1 to knock it back down to 93. So clearly what we're producing is a beta particle. All right, we want to take curium, which is Cm, and it's number 96, and it has a mass of 246, and we want to hit it with something, all right, to produce. Now let's see what we got to do. We're doing nobelium, right, which is No, and it's 254, and nobelium is number 102, and it says we have 4 neutrons. So 10N plus 10N plus 10N plus 10N. So let's look at what our numbers are on top. Over here we've got 254 plus 4, or 258 over here. Now we've got 102 on the bottom plus a bunch of zeros, so 102. So what numbers do I need to add to this to get over to the right-hand side? Well, if I look from 246 to 258, that's a total of 12. And if I look from 96 to 102, that's a total of 6. Well, what do we know? That obviously if it has 6 protons, it has to be carbon. And this is actually the most stable form of carbon. This is carbon 12. So that's what we would hit it with. All I'm doing is matching numbers and making the numbers add up. All right. Beta decay of nitrogen 13. So what we're doing is we're throwing some just standard everyday decay equations in here just so that you don't mess up. Right? Beta decay is a 0 and a -1. So that means this has to be a 13 on top. It has to be an 8 on the bottom. If it says an 8 on the bottom, that means it's oxygen. Okay. All right. How about number 6? We've seen this one before. He took nitrogen 14, which is number 7, and he hit it with an alpha particle, which is a 4 and a 2. And it says that that's, well, let's see, that's 18 and 9. Okay. And it produces oxygen 17. Oxygen is number 8 and 17. And let's see, what numbers do I still need? Another particle, it's going to be a 1, 1, and it is going to be a hydrogen. So that my numbers add up to 18 and 9. All right, so we have a neutron bombardment of molybdenum. Molybdenum is mass of 98. I look it up on the periodic table. It's number 42. I hit it with a neutron, which is 1, 0. And that's going to give me 99 and 42. And it says it's producing technetium. All right, so that's Tc. And technetium is mass number 99, and it's number 43. So to be able to get to 99 and 42, I have to subtract 1 from the bottom number. And if I do that, that is a beta particle. All right, number 8. Calcium 40. You've seen this one before. Calcium 40, and that's 20, and we bombard it with neutrons, which are mass of 1 and no charge, and that produces potassium 40, which is K, and number 19. So I have to have 41 on top and 20 on the bottom, which means I have a 1 and a 1, which is hydrogen. Okay, here's a new one, bombarding aluminum 27. That's Al, that's number 27. Aluminum is number 13. Right? And I bombard it with an alpha particle. So an alpha particle is 4 and 2. That means I have to have 31 on top and I have to have 15 on the bottom. It produces phosphorus. Phosphorus is number 15 with a 30 up on top, which means I have 1 more on the top and I have nothing on the bottom, which means that needs to produce a neutron. All right, this says I'm producing plutonium. I'm bombarding uranium 238. That's number 92, and I'm bombarding it with an alpha particle, which is 4 and 2, which means I have to have 242 on top and 94 on the bottom. I am producing plutonium. Plutonium is number 94. Right, and it says I'm producing plutonium 239. All right, well, what do you notice? My numbers here are off by 3. It says I'm producing neutrons. I have nothing on the bottom to worry about, so I have to have 3 neutrons to match up my numbers. Okay? Does that all make sense? All right, we're halfway there. Let's go ahead and do some more. Number 11. Write the nuclear reaction for cobalt. Cobalt, 59. Cobalt is number 27. And we hit it with a neutron, and it produces cobalt 60. Well, that's pretty simple. Cobalt 60 with 27. Okay, no surprise there. Okay, how about neutron bombardment of gold? This looks like a pretty simple one too. Gold is 197, and it's number 79, and we're hitting it with a neutron. Mass of 1. no charge, produces 198, 79, and that is still gold, and that's what we were looking for. So that's real easy. Oops, excuse me, that's AU. Okay, hydrogen 2. All right, so that's hydrogen, that's deuterium, is bombarded with helium 3, and that's 2. And this produces, let's see, I've got 5 on top and 3 on the bottom. So it produces helium 4, so that's 4 and 2, plus, let's see, well, I've got 1 extra and 1 extra, so that must be hydrogen that I'm producing. Hydrogen 2 is bombarded with hydrogen 3, producing, let's see, 5 and 2, so that produces helium 4, 4 and 2, so what else do I have left? I've got 1 0. 1 0 is a neutron. All right, number 15, we're still getting stuff that's very similar. We have hydrogen 2 is bombarded into another hydrogen 2, okay, producing a single product. Well, that's going to be 4 over 2, which tells me that is helium. Right, completely non-polluting. How cool if we could do that. All right, so we take bismuth. Bismuth is number 83. It has a mass of 197, and it's decaying. And it's decaying into thallium, which is TL, and it says it's decaying into thallium 193. Now, thallium, when we look it up in the periodic table, is number 81. So that means, how much do I have left over on top? I got 4. On the bottom, I got 2. Gee, that's a standard alpha particle. So that's pretty simple. Number 17, rubidium. Well, let's do RB, rubidium 87. And rubidium is number 37. And it's decaying into strontium 87. And that strontium is number 38. So what do you notice with strontium? That's an SR, strontium. Well, the top number doesn't change. The bottom number, you have to take away 1 to manage to get it back to 37. Clearly, that must be a beta particle. All right, number 18, uranium 227. Uranium is always number 92, and it decays to produce thorium 223. Thorium is number 90. So when I go and I do the math here, I notice that I have 4 on top and 2 on the bottom. So that must be an alpha particle. Only a few more to go. Germanium. Germanium is number 71. I'm sorry, it has a mass of 71. It is atomic number 32, meaning it has 32 protons. And it decays. And it emits a beta particle. A beta particle is 0 minus 1. So that means what's left is I still have 71 on top, but now I have 33 on the bottom. 33 on the bottom is AS, or arsenic. Okay, a couple more. Radon 217. And radon is number 86. And that's Rn. And it says it decays emitting an alpha particle. Probably one of the worst alphas I've drawn today. All right, and so what's left? Well, I have to have 213, because 213 plus 4 makes 217. And the bottom has to be 84, because that plus 2 makes 86. Number 84 is polonium, or PO. And finally, the last one. Right, so we take uranium 235. This is a two-step equation. Right, so we take uranium 235, and we bombard it with a neutron. So that produces uranium 236. So we still have uranium. That all makes sense. Okay, it's very unstable, and it splits apart into barium 141, plus krypton 92, plus some neutrons. Let's just put 1 in there just so we remember. All right, we've got barium, and we look up barium, and barium is number 56. Now we look up krypton, and that's number 36. All right, well, 36 plus 56 is giving me 92, so that number balances. How about the top? I got 141, and I got 92. That's 243, right? But I'm not at 2 I didn't do that right. 233, and I'm not at 236 yet. Did I do that right? 141, 92. Let me just put that up here so that I make sure I do it right. 141 and 92. That's a 3. That's a 3. And that's a 2. 233. But I have to get to 236. Well, I'm 3 away, right? So I need to have 3 neutrons. Okay. That's it, folks. If you have questions, please see us in class. We'll be happy to help you. Have a great day. Almost done. Bye.